In this video, we are going to talk about the continuity of the function. So let's consider an example. So our example is discuss the continuity of the function fx is equal to x at x equals to 0. So in order to find the continuity of the function, what I'm going to do, I'm going to consider this function right here. So my function is given as fx that is equal to absolute value of x, right? Now, if I simplify this function, what will happen? I will write this function as negative x when x is less than 0, right? And this function is equal to 0 when x is equal to 0, right? And the function is equal to x when x is greater than 0, right? Now, as you can see, when x is less than 0, function is negative x. When x is equal to 0, function is 0. And when x is greater than 0, the function is x. Now, in order to define if this function is continuous or not, let's first see if the function is defined at x equals to 0 or not. So, at x is equal to 0, the value of the function is what? f0 is equal to what? 0. Because when x is 0 right here, value of the function is 0. So yes, the function is defined. So I can write fx is defined at x is equal to 0. And this is our first condition. Now, let's consider the second condition. So the second condition is we need to find the left-hand limit of the function. So let's find the left-hand limit. So my left-hand limit is equal to limit x tends to 0 minus fx, right? And look at this. We need to find the left-hand limit of the function when x is less than 0. And for that part, this is the function. So I'm going to write this one as limit x tends to 0 minus, and my function is negative x, right? If we simplify, what will we do? We will substitute the value of x as 0. So I will write this is equal to negative 0, which is equal to what? 0. So my left hand limit is equal to what? 0. Now, let's find the right hand limit of the function. So my right hand limit of the function is limit x tends to 0 plus fx, right? And look at the function. This is the point where we will find the right hand limit. And for that point, when x is greater than 0, the function is what? X. So I'm going to write this one as limit x tends to 0 plus, and my function for that part is x. Now, let's simplify further, and the way we simplify is what? We substitute the value of x as 0. So I'm going to write this one as 0 because x is 0, and that is what? 0. So as you can see, the value of the function at x equals to 0 is 0 right here. Left hand limit is also 0, and the right hand limit is also 0. So we can write that limit x tends to 0 minus fx is equal to, left hand limit is equal to right hand limit of the function, right? And that is equal to the value of the function, right? Which is f0. And what is the value of the function? Value of the function is 0. So we can say that function fx is equal to absolute value of x is continuous at x is equal to 0. So the continuity of the function fx equals to absolute value of x is defined at x equals to 0. Let's consider another example. An example is discuss the continuity of the function fx is equal to sine x over x when x is less than 0 and x plus 2 when x is greater than or equal to 0. And what we need to do, we need to discuss the continuity of the function fx at x equals to 0, right? So the example is right there. What we need to do, we need to first find if the function is defined or not. So let's find the first thing. Let's see if the function is defined or not. So my point is x equals to 0, right? So the very first thing I want to do is I want to see if f of 0 is defined or not. So f of 0 is basically what? This is the point right here when we can find the value of the function, which is like f of 0. So for that value of x, the function is x plus 2. So I will write x plus 2. I'm going to substitute 0. So I will write 0 plus 2. And 0 plus 2 is what? 2. So we can say that function fx is defined at x equals to 0. And the value of the function is what? 2, right here. So we have the value of the function. Now let's find the left hand limit of the function. So the left hand limit of the function is equal to limit x tends to 0 minus fx, right? And we need to see which part of the piecewise function we are going to consider for the left hand limit. So if you look at the function, it says x is less than 0 and the function is sine x over x. So basically when x is less than 0, that part of the function we will use to find the left hand limit, right? So this is the function that we are going to use to find the left hand limit. So I will write this is equal to limit x tends to 0 minus sine x over x. Let's simplify further, and if we do that, we will find the limit of function sine x over x, and we know that the value of that function is what? 1. So my left hand limit is equal to 1. Now let's find the right hand limit of the function. So my right hand limit of the function is equal to limit x tends to 0 plus fx, right? And that should be equal to what? Look at the function. This is the point when the function is defined for the right hand limit, right? So I'm going to consider this part of the piecewise function to find the right hand limit. So I will write this is equal to limit x tends to 0 plus my function is x plus 2. Now let's simplify further, and if we do that, what we will do? We will substitute x as 0. So I will write 0 plus 2, and 0 plus 2 is what? 2. Right? Now let's look at the function, whatever we have right now. So as you can see, my right hand limit of the function is 2, right? My left hand limit of the function is 1 right here, and the value of the function is 2. So as you can see, my left hand limit, which is what? Limit x tends to 0 minus fx is not equal to limit x tends to 0 plus fx, which is the right hand limit. So the left hand limit of the function is not equal to the right hand limit of the function. And that is also not equal to the value of the function at point x equals to 0, right? So basically we can say that the continuity of this function is not defined at x equals to 0. So we will write function fx is not continuous at x is equal to 0, right? So basically the continuity of the function fx is not defined at x equals to 0. And this is how we will define if the given function is continuous at any given point or not.